Hello. Hello. Am I audible?
Yes, sir.
Okay. So just wait 1 minute. Allow all the students, then we will start to the class. Okay, so let's start today class. So this is for lab. This session is allotted for lab, electrical machine 1. Okay. So have you performed any experiment in diploma in electrical machine?
No, sir.
Okay. So today we are going to discuss, since we have already started single phase transformer, so we just try to discuss the test of single phase transformer. Okay. So I think all of you familiar with the open circuit and short circuit test of transformer. Just tell me. All of you familiar with the open circuit and short circuit test of transformer? कोई रिस्पॉन्स नहीं कर रहे हो.
Yes, sir.
Open circuit, short circuit test of transformer. Have you?
Sir. We all are familiar, sir.
एटलीस्ट तो थ्योरी क्लास में तो कवर किया होगा ना.
Yes, sir. Theory में पढ़े.
Okay, fine. So why we have performed the open circuit and short circuit test of transformer? क्यों करते हैं हम लोग ओपन सर्किट शॉर्ट सर्किट टेस्ट ट्रांसफार्मर एंड हाउ वी कैन परफॉर्म दैट वन? Okay, fine. So just try to recap if all of you forget about these things. I think so. Just we try to discuss these things. So how we have performed and what is the how we can measure all these things. So Actually, we are already familiar with the equivalent circuit of the transformer. So with the help of these two tests, that means open circuit test and short circuit test of the transformer, we can find the equivalent circuit parameter. Okay. What are the parameters in the equivalent circuit of the transformer? At least you just mention this point. What are the equivalent circuit parameter of the transformer? Primary winding resistance, primary winding leakage reactance, secondary winding resistance, secondary winding leakage reactance, core loss resistance, and magnetizing reactance. Is not. So if
Yes,
we
sir.
if we perform these two tests, we can find the all the parameter of the transformer. Okay. So first one, if you concern about the open circuit test, that means as you maybe observe from the name of open circuit, that means yes, someone telling something. Hello. Okay, fine. So for the open circuit test, that means we are not apply any load on the transformer. So whatever the power consumed during this test, we consider as the core loss of the transformer. Okay. So with the help of these two tests, we can find equivalent circuit parameter as well as the efficiency of the transformer, because the two losses we already find out with the help of these two tests. That means open circuit test and short circuit test. Uh, core loss and ohmic loss. If core loss and ohmic loss we can find, then we can find out the efficiency of the transformer. So you know, so we can find these various things with the help of these two tests. So just first of all, try to share the screen. And so with the help of these two tests, we can find out equivalent circuit parameter and efficiency of the transformer. Next point, how we can perform these two tests is not. How we can perform these two tests. At least all of you familiar with the electrical instrument, either what measuring instrument or some transformer, electrical motor.
Yes, sir.
Okay. So if you want to measure the perform the no load test, that means we require transformer, one transformer, and for the measuring instrument, that means so for the voltage measurement we required voltmeter, and current measurement required ammeter, and power measurement required wattmeter. Okay. So if the instrument we have, then we can perform the no load test of the single phase transformer. Is not. So just see here, we just try to perform these two tests with the help of virtual, since we are not able to physically perform. Okay. Whenever it is possible in a later time, we can perform these tests in the laboratory with the physically. Okay. But today we just try to perform these tests with the help of simulation. That means how we can experiment can be done with the physically in the laboratory. So today we are going to experiment number this one. You may find out various type of experiment here with the help of simulation. So we are going to discuss today determination of transformer equivalent circuit from the open circuit and short circuit test. Okay. So just click here. That means, so we already explained that the what are the aim for performing these two tests, that means open circuit and short circuit test. So first of all, you keep in your mind why we are going to perform these two tests. Okay. Then next, what is the theory and how we can find these parameter. First one, we already explained that we can find the equivalent circuit parameter. With the help of theory, we can just try to calculate all the parameters of the equivalent circuit. That means primary winding resistance, secondary winding resistance, and secondary side resistance, and secondary coil leakage reactance. Okay. So first we'll just go through the theory part. Whatever the so sorry. Okay. So introduction of this part, that means open circuit performance and short circuit test for the finding the equivalent circuit parameter of the transformer and their efficiency. Okay. If we also connect the voltmeter when we perform the no load test, then we can also find the secondary side voltage. So with the help of that, we can also find the voltage regulation of the transformer. Okay. So these are the advantage, and we can find the various parameters if you perform the open circuit and short circuit test of the transformer. So these tests are performed without the actual loading, and because of the reason the very less power is required for the test, the open circuit, so we can perform this test in the laboratory with the standard supply voltage available in our laboratory for the single phase transformer. Okay. So the open circuit and short circuit test gives a very accurate result as compared to the full load test. So how we can perform the open circuit test? Open circuit test we just perform at the rated voltage. Okay, the rated voltage of the transformer. So for perform this open test of the transformer, we connect all the measuring instrument towards the low voltage side of the transformer and kept the high voltage side open. Okay, you already know that the two winding consist in a transformer. One is known as the LV winding and another is a HV winding. Okay, so during the open circuit test, we connect all the instrument on the low voltage side and keep the open of the HV side winding. That means whatever the high voltage winding in the transformer, and just try to keep the supply at the rated voltage of the low voltage winding with the help of variac or auto transformer, single phase auto transformer. Okay, so we can just measure whatever the rated voltage of the transformer supply given to the primary coil or LV coil. That is more accurate for LV coil if you say that LV coil. And during that period, what current supply taken from the supply side, so that can be measured with the help of ammeter. And similarly, one wattmeter we have to connect on the LV side. Okay. So we change the variac or auto transformer position, and we observe that when the voltmeter record the rated voltage of the LV side, then we stop the movement of the auto transformer. Okay, and at that particular instant, we require to note down all the measuring instrument reading. So which type reading we can observe with the help of open circuit test? That means supply voltage of the LV side, that is rated supply voltage, and next one is current and power. So these three quantity we have to note down at the rated voltage. Okay, so you may be consider that the wattmeter reading during this open circuit test, whatever the power indicated by the wattmeter reading, that we can consider as the core loss. Okay, because the core loss is directly proportional to the square of the voltage. So we drive this equation in the theoretical class also. Okay, so we are not going to that point today right now. So we just concerned about whenever we perform the open circuit test, that means power measured by the wattmeter is assumed as the core loss. Okay, because the ohmic loss is considered during the short circuit test. Here the at the rated voltage we consider the core loss. Okay, so we find out here the circuit diagram and connection for the open circuit test. Okay, so these are the circuit diagram where how we can connect the wattmeter. This one, anyone? Which measuring instrument? This one, just tell me. Hello.
Yes, sir.
What is this instrument?
Watt meter, sir.
Wattmeter actually. And can you give me the name of these two coil?
Which,
Current
sir?
coil, sir.
Sorry, not getting your point.
Current coil.
Current coil. And next one,
Moving coil, sir.
moving coil. So which one is moving coil and which one is current coil?
ML, sir. Current coil, sir.
Here marked with the terminal. So this coil is marked as the terminal M and L, and this coil is marked as C and V. So just tell me which one is current coil and which one is moving coil, or maybe say that another name, pressure coil also. Okay, moving coil is also known as pressure coil. So just identify and tell me which coil is current coil and which coil is pressure coil here in the wattmeter.
Sir,
M-
VC is moving coil and
Just clearly tell me what if you're wrong, doesn't matter. If you're wrong, then we will just correct here. So don't hesitate when you respond, anyone. Don't fear about the either wrong or correct answer. So just clearly tell me which one is current coil and which one is moving coil.
ML is, sir, current coil, sir. And VC is moving coil, sir.
Exactly. ML is your current coil and this one is your VC is your moving coil or pressure coil. So these are the two coil in the wattmeter. Okay. So you will find out in analog wattmeter, that means these two terminal for the current coil and these two terminal for the pressure coil. Okay. So on the analog wattmeter, you will find out the four terminals M, L, and CV. So you kept in your mind the terminal of current coil, that means M and L, and pressure coil C and V, so that you are able to connect a wattmeter when you perform the open circuit. Okay, because in analog wattmeter you maybe observe that four terminal point mark. Okay, so when you connect according to the circuit. Okay, so one, I think this this is down here. Okay, this one is actually voltmeter and this one is your emitter. Okay, you cannot connect this way. So you have to keep it in your mind. This one is your emitter, is it not? And here we connect voltmeter. So this is the circuit equivalent circuit diagram connection for the open circuit test. Okay. So here you will find out indication of these two coil is one is your LV coil, another is your HV coil. Okay, here not mentioned, but you assume whatever the instrument connected, that coil is LV side. Okay, and this one is your HV side. So when we perform this open circuit test, so whatever the measuring instrument we connect through the LV side. Okay, and HV side kept open. So you will find out here no load supply connected through this coil, that means a LV side, sorry, HV side. Okay. Then if you connect all the emitter wattmeter and voltmeter according to the circuit. The next point is our move this variac. This is your moving point of single phase auto transformer. We say that. So whenever you move this point, you maybe reflect the voltmeter reading where you connect the voltmeter here. So you observe that this voltmeter indicate the rated voltage of this LV coil. Okay, this LV coil. And then if you observe that the voltmeter indicate the rated voltage of the LV coil, then you stop the movement of this moving point or single phase auto transformer. And at that instant, you note down all the instrument reading. That means voltmeter, ammeter, and wattmeter. Okay. So this is the all about the open circuit test. If anyone have problem, next just with the help of calculation also. Which parameter we can find out? So this is all about for the no load losses, and which parameter we can find out with the help of this open circuit test. At this instant, you will find out no load current supply given to the load. So whatever the current drawn from the supply is known as exciting current. At this instant, whatever the current taken from the supply is known as the exciting current of the transformer. Okay. So exciting current you will find out very small compared to the full load of the transformer or rated load of the transformer. That's why we are neglect here ohmic losses. Okay. So whatever the loss we assume here, that is core loss. Okay. Since the test performed at the rated voltage. Okay. And core loss is directly proportional to the square of the voltage. So we neglect one more point. You may find out what is the no load current for the transformer. Anyone have idea about the no load current of the transformer? Hello. नो लोड टेस्ट परफॉर्म करने के लिए नो लोड करंट का वैल्यू कितना होता है ट्रांसफार्मर का? 2 to 6% of the rated current of the transformer is required for perform the open circuit test. Okay. So whatever the rated current of the transformer, only 2 to 6% required. Okay. So you may be note down here that means the ohmic losses is how much I square R loss is known as the ohmic losses. So ohmic losses you may find out how much 0.04% of the rated ohmic loss to 0.36%. Okay, so that's why we neglect here the ohmic losses. Okay, that is very small compared to the core losses because the 0.04% of rated ohmic loss take place in the open circuit test. Okay, so you have to keep in the 4 point in your mind when you are performing the open circuit test. That means why we are going to perform the open circuit test and how we can perform and which power consumed during the open circuit test. So is it clear to all of you or have any question? Just ask about the open circuit test. Hello.
Sir,
Yes, sir.
Is it clear
sir,
to
I
all
have
of?
a question, sir.
Yeah, just tell me.
Sir, why we perform the open circuit test in LV winding, sir? Why we do not perform the test in HV winding, sir?
Exactly. So this is a very important question where we have performed the open circuit at the LV and short circuit on the other side. Okay. So you may be observe that in a transformer, okay, standard level transformer, LV side voltage and HV side voltage. Okay, so LV side voltage, since we require core loss component. Okay, so core loss is directly proportional to the square of the voltage. Okay, so these low voltage coil is, we are able to find the standard instrument in the laboratory. Okay, suppose that this transformer rating, you may find out 230 volt at the LV side. Okay, and obviously higher than compared to this LV side voltage is at the HV side. Okay, so the instrument may be not a standard, you may find out when you perform the open circuit test at the laboratory. Okay, because this is a standard instrument or measuring instrument, you will find out a standard range, that means 230 volt or maybe 440 volt. Okay, so we require rated voltage, so we are able to that type of measuring instrument available with our hand, so we can connect during that open circuit test. Okay, but when we observe that when we are going to perform this short circuit test, okay, so short circuit test is performed at the HV side, because we know that when the short circuit test, that means rated current required flow during that test. Okay, so for the rated current, we require to the 2 to 12% of the rated voltage. Okay, so suppose that 11 kilovolt at the HV side and 230 volt single phase at the suppose that how we can just yeah, 11 kilovolt HV side and 230 volt at a single phase at the LV side. Okay, if you consider three phase, then you may find out the line voltage 440 volt gas plus, is it not? So when we perform the short circuit test at the rated current, so only we require 2 to 12% of the rated voltage of the HV side for flow the rated current. Okay, so you may find out the what is the voltage required for the short circuit current. If 11 kilovolt voltage rating of the HV side, so what is the voltage required for the rated current flow in the winding? Hello. Hello.
Yes, sir.
What is the current sorry, voltage required for the 11 kilovolt of the HV winding? So key factor is these 2 points. That means we have performed at the rated voltage, so measuring instrument is available in that standard range, whatever the measuring instrument. That means 230 volt voltmeter. So we are able to measure that voltage. Okay, and if you required, suppose that this open circuit test you perform at the HV side, then you require to rated voltage of that winding. So you are not able to measure the 11 kilovolt with the standard measuring instrument. Is it clear why we have performed the LV winding for the open circuit and HV winding for the short circuit?
Yes, sir.
Okay. So these 2 points you have to keep. For the measuring a standard measuring instrument, we are not able to measuring instrument in the 11 kilovolt or something like that. Okay. A standard voltmeter and emitter, either you maybe find out 5 ampere or 10 ampere emitter reading, rated measuring rating of the emitter, and 230 volt and 400 volt, 440 volt up to, or single phase 230 volt. You can easily measure with the help of a standard measuring instrument. But if you connect or perform the test, open circuit test on the HV side, then we require to how much? Measure the HV side, that means 11 kilovolt. That is not sufficient to measure with the help of a standard measuring instrument. Okay, that's why we perform the open circuit test at the LV side. Is it clear to all of you? Hello.
Yes, sir.
Okay, fine. So this is very important question. You may be kept in your mind. Anywhere, may frequently ask this question. Why we have performed the open circuit on the LV and why we performed the short circuit on the HV side. Okay. So one more thing, if this one period is over, then you just again rejoin within the 2 minutes. Okay, for the second period, so we can continue this session. The session lab is for the 2 period. Okay, so whenever disconnected when the time up for the first period, then you will just join second time within the 2 minutes or 3 minutes, so we can continue these things. So I think is it clear to all of you all about the open circuit test, or I still have any question? Anyone then ask me, or otherwise we move to next point about the short circuit test. Have any question, anyone, regarding the open circuit test? किसी को कोई क्वेश्चन इसमें ओपन सर्किट में क्यों करते हैं, कैसे परफॉर्म करते हैं सर्किट टेस्ट, एंड क्या हम लोग को ध्यान में रखना है जब हम लोग परफॉर्म करेंगे इसको टेस्ट को, तो क्या क्या रिक्वायरमेंट होगा, व्हाट इज योर रिक्वायरमेंट फॉर परफॉर्मिंग दिस टेस्ट? So is it clear to all of you, or just tell me?
Yes, sir. Clear.
Okay. So this is all about the open circuit test. Next we just try to. So with this help, we can find out, obviously, that means core loss resistance. That means RC. If you consider here core loss, okay. Another parameters is your magnetizing reactance. So how we can represent the core loss resistance and magnetizing reactance? RC and XM. You know, in the equivalent circuit, we can represent the core loss resistance. Amisha, anyone? Sorry, just 1 point. Okay, so you have to keep in mind this circuit diagram and instrument connection. So similar things we can move to what we required here. So what is the standard notation? That means wattmeter and voltmeter and ammeter. Okay, so you have to note down all the reading. That means wattmeter, voltmeter, and ammeter. Next, about the calculation through the open circuit test, we parameters just find out for the core loss resistance and magnetizing reactance. So we already measure the power, that means no load power consumption, that is core loss. So that power can be represented as the how much? Vi cos phi, is it not?
Yes, sir.
So
Yes, sir.
we just try to find out the no load power factor, that means cos phi. We already measure wattmeter reading, that means W0, and voltmeter reading and ammeter reading. So if you put on this formula, then we can find out the no load power factor. Is not cos phi equal to active power divided by V1 I0. You may find out this notation. Some standard book you may find out represented this no load current by the IE. Okay. Some students are still joining. Okay, so you will find out this notation, some standard book also, that means IE, exciting current. Okay, so if you put the wattmeter reading, voltmeter reading and ammeter reading in this equation, then you are able to find out the no load power factor. Okay, so already explained that this no load current consists of two components. One is your core loss component, another is your magnetizing component, XM. Okay, so just how we can find out, I think, have you remember the phasor diagram for the no load of the transformer? Anyone? So if you have remember, then you may be observe with the help of phasor diagram. That means core loss current IC is nothing but I cos theta 0, is it not? I cos theta 0, or maybe represented by phi, then I cos phi. And magnetizing current component is IE sin phi, is not? So if we find cos phi with this formula, then we are able to find out IC and IM, is not? So RC इक्वल टू हम लोग कितना लिख सकते हैं? Supply voltage by resistance. The V equal to IR. That means if you want to find out the RC, so V1 supply voltage divided by IC, is not? That means core loss current of the exciting current. Then we can find out another parameter, magnetizing reactance. That means XM. XM equal to कितना होगा? ध्यान में नहीं है तुम लोग को फेजर डायग्राम या तो